you guys believe that it is the last week? This is going to be the last week of our classes technically. So remember that this is the last week that I'll be taking attendance for the class. But we can definitely do a review session for the final next week also during our regular time if you guys want to do that. So just need to know what you guys want to do.
That would be awesome. Thank you.
So maybe just a few things that I heard that I want to make sure you guys know about, and I'll send it out an announcement to you guys too. Your Math 980 teacher should also be letting you know about this as well. But so when you're taking the final exam, you are going to be taking it on Canvas, so it will look really similar to your Canvas quizzes that you've taken all semester long. But there is something you got to be careful about. So remember that you said you can use your notes, your own personal notes you'll be able to use on the test, and you'll be able to use a scientific calculator, but you can't use, other people or, anything like that. So part of that means that you can't use your past assignments or quizzes or the videos that are on Canvas or anything like that. Because, if you do go in and try and access one of those things while the final exam, while you're taking a final exam, it will kick you out of that immediately, and you will get a 0 on your final exam. So I just wanted to make sure that you guys were aware of that. So, because it's just, I don't know. That's what they decided to have happen. So anyway, just wanted to make sure that that was clear to you. So just don't try and access anything. It doesn't matter if you access it from the same, computer or a different computer. If you try and get into something else while the final exam is open, okay, it will be bad for you. So just use your notes and stuff that you have and you'll be good. Okay.
I have a question. Have you heard anything about, on the past exams, we would get credit for our work? Is there going to be some kind of way we scan our work in, or is it just going to be strictly multiple choice? You're right.
Yeah, there's not going to be any work that you're going to be turning in. And they did that just because they've tried doing it with some of the other math classes. And, I don't know, there's been several students that have, struggled to get that in, because if they do that, then you have to make sure that you get your work turned in the amount of time that you're given to take the test. And so anyway, it's just been more of a hassle than help. But what your instructors should do and have been told to do is, after you finish the final exam, that they should go in and look at your answers and make sure that, if you have the answer correct, but somehow you just put it in a way that the computer didn't like, that they should still go ahead and give you credit for that. So that's the only thing that, that they'll be doing. So they won't be looking at the work, but they can look at your answers and just make sure. Do you know what I mean? Because sometimes some of the questions, the way you put it in.
Just like in the homework.
Yeah. So yeah. So good question though, right? You're not going to be turning in any of your work on this, just like the quizzes. Okay. Miss Shayla, did you have a question too?
I don't.
Okay. You have your hand up. So, oh, Miss Shayla, not Shayla. Sorry. I know we got a Shayla and we got a Miss Shayla. Oh, and Miss Shayla just left. Okay. I don't know. Okay. Well, are there some things that you guys want to start talking about today? If there's, questions from homework and stuff like that. I don't know how many of you in your classes were able to talk about the very last session or, section. But that is one that tends to give students a lot of issues, and so I thought, well, we could talk about 6.8. Whether you've gotten there or not yet, you probably want to have a little extra help on that. At least in the past, that's been the way that most students have needed some help there.
We finished 6.8 yesterday, and I'm a little lost.
Yeah, they're kind of weird questions. I mean, and I thought we could even I could pull up the homework and we could look at some specifically, because the problem is the way that they put some of the questions into the homework are they're usually different, and so some students get lost because they're like, well, this wasn't like what we talked about in class. It is, but then there's more things that you have to do on the homework, and so we can definitely go through some of that. Alex, did you have a question?
Yeah, I had a question on 6.6.
6.6? Okay. Well, let's start there, because I definitely will get to 6.8, but let's take take any questions that you guys have up to that point, because we definitely want to make sure that we talk about 6.8, but let's get everything before then. Did you have something specific, a question that you want to look through?
Yeah. Are you good if I just type it in the chat?
Or you can just tell me, and I'll just write it up here. Oh, whoops, I'm not sharing my screen with you, so you guys can't see what I'm... Oh, sorry, I thought I already shared it with you. There we go. All right.
Okay, ready?
Mm-hmm.
All right, so it is 5 to 2x minus 2.
To the power of?
Yes.
Okay.
Equals 48.
Okay. Good. Yeah, this is a good one to look at. So, when you're trying to solve these exponentials, right, there's one thing that you talked about, and, sometimes it's easier. There's a property that says if a to the m power equals a to the n power, then, right, m equals n. Right? So if we have the same bases, then we can say our powers are equal to each other. Right? So if I had something like, 2 to the 4th power equals 2 to the x power, then I know that x equals 4, right? Or we can get those bases to be the same. But on this one, we cannot get those bases to be the same. And so remember that logarithms and exponentials undo each other, right? And so that's the whole reason, whenever there's a way to do something in math, there's always a way to undo it. And so in this case, since we can't get the bases the same, like in my example over here, we've got to take the logarithm of both sides. And it doesn't matter if you use log or the ln button, the natural log or the common log, but you've just got to make sure that you use the same thing on both sides, right? Whatever you do to one side of the equation, you do to the other side. And make sure also it's clear, I mean, it seems weird to a lot of people, that log, this is an operation, right? Like, add, subtract, multiply, divide, square root, all of those different kind of operations that we have in math. Log is also an operation. So sometimes people look at that, and when they're trying to solve it or something, they think, oh, I've got to get those letters by itself. So these aren't variables, right? This is an operation. So let's go ahead so we're taking the log of both sides, right? It's the first thing that we're going to do. And then when we do that, there's a property in our with our logarithms that says our exponent can come down in front and can be multiplied by that log. And that's important because right now, where that variable that we're trying to solve for is the exponent, we can't solve for it there, right? So that's why we have to take the log of both sides, because then we can use that property that says, okay, I'll bring that out in front. So it will look like this. So I'll have in parentheses my 2x minus 2, and that's going to be multiplied by the log of 5, and that's going to equal the log of 48. Right, and like I said, if you use natural log instead, that's fine. It doesn't matter. Just make sure you're using the same kind of log, right, on both sides. And now we're trying to solve it for x, right? So we're trying to get everything over to the other side that's not the x. So the first thing we want to do is we need to get rid of the log part on this side. So we're going to start by dividing both sides by the log of 5. Okay. And then that's going to give us, right, so the log of 5's cancel out, and then we'll have 2x minus 2 equals the log of 48 over the log of 5. Okay, and at this point, I'd start putting things into your calculator, right? Because oftentimes on these, they ask you for a decimal approximation. Did it tell you where it wanted you to round this answer to?
It did not say any kind of rounding. It wanted the whole thing.
It wants the exact answer?
Yeah. And the way that the video, like if you want to help, the way the video explains it is completely different than what you're doing. They want you to distribute the 2x and the negative 2, and then go from there.
That sounds brutal. That does not sound like a very good idea. So, I mean, if you were going to write your, in exact form, which I really thought all of the questions said that they were going to have you round them, but I'll go back and look and see. But because like in 1050 and stuff, you're going to start talking, you're going to talk more about logs, 1010 and 1050. You'll see that these will come back up again. But, so if you're supposed to keep it in the exact answer, then you're going to leave it in log form. So you'd have this, right? But x is still not by itself yet. We need to, just think about if you had, something like, 3x plus 5 equals 7, right? We'd subtract the 5 over first and then divide by 3. That's the same thing that you're going to do here. So to get x by itself, we're going to add the 2 over, right? And so then I'd be adding the 2 over here. So log of 48 divided by log of 5 plus 2. And then the last thing that we need to do there is divide by this 2. And so we'd have to take that whole thing and divide by 2. So this right here is your exact answer. Like I said, like usually I've just seen this, like them wanting the, let me just look in the homework really quick again.
They wanted the decimal out of all of that.
Okay, yeah, that's what I thought. I was like, that just doesn't seem like they want the exact answer there. But they should tell you where to round to, because you can't put the whole thing in because it's going to be a never-ending, non-repeating number. And so they have to tell you where to round this to. And so usually it's 4 decimal places is what they want for their answer. And they'll have kind of a little bit of a rounding error where they'll give you credit if it's, off by a little bit. But, let's see. Let me just look and see here. Yeah, I think most of them say round to the nearest 10,000th, so that's to 4 decimal places. So let's try and put this in your calculator, right? So the first thing that you're going to do is put in that log of 48 divided by the log of 5. And sometimes on your calculator you'll have to do log of 48 equals and then divided by log of 5 equals. Depends on your calculator, but that will work on all of the calculators. Okay, so check that part out first of all. So the log of 48 divided by the log of 5, just that first part, should be about 2.405, blah, blah, blah. Everybody get that?
Yes.
Okay. Then, let's see. Let's see what, didn't have my chat box open and I saw that there were some messages there. So, he says, my end is freaking out. I can only hear robo voices. Does it sound weird to you today? Those of you that can hear me?
No, I'm good.
That's so weird. Yes, I will be recording it though. If you need, you know, to go back and watch it and stuff. Just remember, if you go back and watch it, just to let me know that you got it watched. Okay, so that part, that's the log of 48 divided by the log of 5 is the 2.405, blah, 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 right? Then keep that whole answer in your calculator, right? You're not rounding it until the very, very last step. So then keep that number in there and put plus 2, right? Because we're going to take whatever that answer is, just like it is, add 2 to it. And then take our answer that we have and divide it by 2. Right? So you end up with something that is like 2.20, let's see, 2656, blah, 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 right? But it says to round to the nearest 10,000, so that's 4 places, 4 decimal places, so that's here. So 5 is big enough to round that up 1, so the answer that we'd put in is 2.2027. Right. Are you guys able to get that with your calculator?
Yes.
Okay. So the order that we do things in, right, matters in math. So you got to make sure that, you know, the way that we're moving things over is in that form. Okay. What other things can I clarify on that one?
That was much better and easier than the video tried to explain it.
Yeah, and also with the graphing of logs and stuff, the video explains it in a really, I don't know, they're making it harder than they have to. I don't know why. So I think I talked about last week the graphing of the logs in our class, didn't we?
Yes.
Okay, so I would definitely, try and change those to exponential form first. It will definitely be a lot easier than the way they're explaining for you to do it. Okay. All right, was there another one on 6.6 you wanted to look at?
Yeah, I have one more.
That's great. Okay, and anybody else, please speak up if there's other ones that you wanted to do. Okay, let's look at that other one. Alex, what was it?
All right, so it's going to be 4 to the power of x plus 5.
Okay.
Equals 8 to the power of x minus 3.
Okay. So with this one, we can get the bases to be the same. So you have options here. You could do the same thing that we did on the last one and take the log of both sides. It will take a little bit longer to get your answer, but it will work. Okay, so I'll kind of show you both ways. So the way that I would suggest is to try and get, so I'm looking at both of those and saying, oh, I could do 2 to the something power is 4, right? And 2 to the something power is 8. And so if I can get those bases to be the same, like I talked about, at the top, well, on that other problem, it's going to be faster for you. So let me show you that. So if we said, all right, so the base, 4 is 2 to the second power, but then I have to take that 2 and multiply it by that x plus 5 that was already there as a power, right? Because remember, when we have a, power to a power, we're multiplying those together, right? So we're doing 2 times that. And then on the other side, right, 8 is 2 to the third power. And then I need to multiply the 3 by that x minus 3. Right? And now I can see, awesome, my bases are the same, so that means I can just set my exponents equal to each other. Right? So this, I'm going to set equal to this. So when I do that, I have 2 parentheses x plus 5 equals 3 parentheses x minus 3. And we can just forget about those bases because they're the same base. We don't have to work with those anymore. All we're working with now is just the exponents. All right, and so let's distribute through here. So that would give me 2x plus 10. And on the other side, I've got equals 3x minus 9. All right, so I want to get my x's on one side and my whole numbers on the other side. So I'm going to choose to subtract my 2x over this way, which will give me just x. So I've got 10 equals x minus 9, and then I'll add my 9 over. So, right, so I get x equals 19 there. Okay. So let me show you. If you did this the other way, right, using logs and stuff, you still will get the same answer. Because I have sometimes students are like, sometimes I have a hard time figuring out these, especially when they're pretty big numbers, like 256 or something like that. They're like, I'm not sure what that base is supposed to be, and that's kind of confusing to me. So I've had some students that say, I just like to do, the logarithm, every time, just to keep it consistent. Okay, so if we do that, right, we'll take the log of both sides, and then remember that number, or that exponent comes out in front, right? So I can move this out in front and this out in front, right? So then I get, let's see, I'm trying to do this. So if we have x plus 5 equals the log of 4, and then x minus 3 equals the log, or x minus 3 times the log of 8. Okay, and so we have, kind of a couple of different things going on here, right? And maybe this is where they were kind of showing you to, distribute through things and stuff like that. And that can get a little bit, messy on these. But if you do, let's see. I think if we want to go down this road at all, I mean, we can, but so since these are connected by multiplication, right, I could, divide to get 1 over on the other side. And so, get something here. Yeah, just 1 second. I'm trying to see if there's going to be a better way to do this. Yeah, so if you do, so I would start off kind of like this. Let's move this over here. Okay, and if at this point, right, you do the log of 8 divided by the log of 4, you get the answer 1.5. And so that actually makes it a little bit easier because you don't have all of those, you know, the log business going on and stuff. So you could do x plus 5 equals, remember in this changes to just be 1.5. So then we get 1.5, right, times x minus 3. And then I could distribute that 1.5 through rather than having to try and like distribute a log through, because that just tends to get kind of messy there, right? And so then I can distribute that through and then make sure I'm getting my x's all together on one side and my whole numbers together on the other side. Okay. Let's try that. All right, so I'm just combining those together. Let's see. Let's keep yourselves muted unless you're talking, okay? Because otherwise we get crazy feedback. Okay, so let's see. So then I could, doesn't matter which way I move this, maybe I'll just subtract my 1.5x over, right? And so then I get 0.5x equals negative 0.5, 9.5. Right, and then when I divide that out, I still get x equals 19. So I get the same answer either way, but look at how much crazier, right, this is over here, where this one's more straightforward. And so if you can get those bases to be the same, I suggest that's what you do. Is anybody kind of having a hard time, you know, figuring out, like, so if you're looking at this 4 and the 8, like, you know, trying to decide what you were going to change it to? Or what?
No, these numbers for me were pretty straightforward. It was just, I messed up at the bottom because of my handwriting, which is
Oh.
but had I not, I would have gotten the same thing.
You would have, okay.
Yeah, but the main thing for me in this, so far, this whole thing is just remembering to put either log or ln in front of things and
Yes.
start moving things around so they match up.
Yeah, yeah, exactly. And so, I mean, really, like, this way, I mean, it's doable this other way, but, you know, and you will get the same answer, but I just highly suggest that you try and, if you can do this way, do it this way, because it's more straightforward. You have less chance of making mistakes, really. There's just a lot of different places where you could make some mistakes in here as you're trying to solve for x. So it's just, you know, just kind of watch that. But yeah, well, that's good that you had it set up the right way and everything like that, because sometimes that's just, you know, you're like, where is my mistake? Am I setting it up wrong? What, you know, is happening there? So, but yeah. So, yeah. Let's see. Shayla, did you hear me say that I am going to record it? I don't know if you can hear me or not. Okay. All right. So let's take some other questions. So, anybody else have some? Those were great ones to look at. Thank you, Alex, for asking about those.
Yeah, I got one more.
Okay.
you ready?
Let me get here. Yep.
Okay. It's going to be e to the power of 7x.
Okay.
Equals 17.
Okay. All right, so on this one, since our base is e, we have to use the natural log to undo it. So this one, we don't get a choice on whether we use the log, right, to undo it, or that ln button, right? So remember, I mean, a lot of people think that it looks like in on their calculator, but it's a lowercase ln, right? So that's meaning natural log, right, or log, because I said you could use one of these, you know, operations on here, but remember, when we have a base of e, we have to always use natural log with it. That's undoing it, because natural log is always in the base of e. Okay, so this one, let's do the natural log of both sides. Okay, and then remember that that means now that 7x gets to go out in front and become multiplied by that. All right, so we get 7x times the natural log of e equals the natural log of 17. Okay, but I want you guys to put something into your calculator, because there is something that you need to know. So if you, on your calculator, find your natural log button, right? So I want you to figure out what the natural log, and some of your calculators you'll have to put e to the first power, right, to show that it's e to the first power. But I want you to see, what is the natural log of e? Because this is something that you should have memorized, okay? Because it's going to be coming in so handy for you if you do. Anybody come up with one there? I know sometimes it's tricky knowing how to put it in your calculator, and so got to make sure you know how to do that.
Is it 2.7182818828?
So that's just e. So that's what e is. So now take the natural log of that number.
It's 1.
Yeah, it's 1. And so that's what I said. So this is something that I want you to have memorized, okay? That the natural log of e equals 1. All right, well, why does that help us? Well, look at over here in our question. We've got this natural log of e right there. All right, so rather than having to work with this natural log at all, right, we know that equals 1. We just figured that out, that that was 1. So basically, that kind of just, you know, cancels out. It's just a 1 here. So we really have 7x times 1 equals the natural log of 17. And then look at how much easier that makes it for us, right? So now all we have left to do to get x by itself is just to divide by 7. So in your calculator, you'll just put in, figure out what the natural log of 17 is, and then divide that by 7. You're not dividing it by the natural log of 7, just 7, right? And so you should get something like 0.4047, and then there's a 4 after that, so that's not going to be big enough to round it up. So if we go to 4 place values, that should be your answer. Okay, I want everybody, make sure that you've tried this on your calculator. You know how to put that in. And if you're not getting that for your answers, let me help you get that figured out. I know everybody's calculator is a little bit different, but you are going to be sunk on the final exam if you do not know how to use your calculator with the logs, because most of the stuff on there is going to require you to know how to use your calculator on any of the log questions. Is there anybody?
I just wanted to add, I figured out how to store the answer, and you could go back into the original and plug it in for x, and you could like check your work that way.
Yeah, definitely. So some calculators you can kind of go back up. If you have a calculator that scrolls, meaning you can like press an up arrow to get back up to some of your equations and stuff, that's nice, right? And you can kind of do that. There's, so many calculators have different ways that you can do things. But yeah, you figure out, like how to best utilize your calculator, right? That's not cheating. That's just, working smart, to be able to do the best that you can on your final exam. Okay, so if you haven't figured out some of those things, play around with it, or, ask me about it. Okay. All right, let's look at one other one. And somebody on the chat want to do this one. This looks like it's also from 6.6. So let's look at this one. So this one says 84 to the x minus 2 power equals 16 to the x minus 1 power. Is that right, Shayla? Do I have that written down right?
No, it is the exponent is 4x minus 2.
Okay. So it should be 8 to the power of 4x minus 2?
Yes.
Okay.
Right.
All right. That makes more sense, because I was like, this doesn't seem like quite what they'd have. So 8 to the power of 4x minus 2, like that?
Yes.
Okay. So so on this one, right, we're going to look at our bases, and our bases are not the same. But how could we get them to be the same? Anybody think of what we could do there to make these bases so they are the same? And if you're not sure, yeah, they're multiples of 2. And so if you're not sure exactly, how to get that, and that's what I was wondering, if some people are kind of struggling to know, how do I rewrite these? One way that you can do this is you can find the prime factorization of those numbers, and that is going to help you know how to write these better. So let me do that on this one, because I'm not sure if everybody knows that they could do this, right? So start with 8, break it down to 4 times 2, and then 4 breaks down to 2 times 2, right? So then we can see, oh yeah, 8 is 2 to the 3rd power, right? And then if I do 16, and I break it down, well, that's 4 times 4, and 4 breaks down to 2 times 2 and 2 times 2. So 16 is the same as 2 to the 4th power. Right, so if you're struggling to figure out what to change these bases to, just do a little factor tree and get those broken down to all their prime factors, and then you'll have, right, what you need. Right? So then I'm going to change that, right? So 8, it's no longer going to be 8, it's now going to be 2 to the 3rd power. Right, so I'm going to put 2 to the 3rd power, but then remember, I still had that 4x minus 2 up there. So I've got to do 3 times the 4x minus 2. Right? Whatever my exponent is now has to be multiplied by the exponent that was already there. And then on the other side, right, 16 is going to change to 2 to the 4th power. So 2 to the 4th power, and then I still need to multiply that 4 by the x minus 1. Right. Okay, let me stop at this point and make sure everybody's with me. What questions do you have to that point? Because oftentimes it's on this first step where things tend to go wrong for a lot of people. Okay, well, let's look at it now. So now, right, our bases are the same. So that's awesome. That's what we wanted to try and have happen, because now we can set our exponents equal to each other. So we're just going to make a new equation that drops off the bases of 2. We don't need those anymore. And we'll just have 3 times 4x minus 2. Right? Make sure you have that 4x minus 2 in parentheses, because you have to distribute that 3 through to everybody. And then 4 parenthesis x minus 1. All right? So then we'll distribute at 12x minus 6 equals, distribute on the other one, 4x minus 4. So let's get the x's together on one side. Okay, so that gives me 8x minus 6 equals negative 4. And now let's add the 6 over. So 8x equals 2. Right? And then I still have to divide by 8. So x equals, well, 2/8 will reduce to be 1/4. So make sure you have your answer all the way reduced. And so x equals 1/4 is your answer there. Does that help?
Yes, thank you.
You're welcome. All right, and so hopefully you can see, even if you get big numbers or weird numbers for your bases there, just do the prime factorization of it. It really is going to be the easiest way to figure out, you know, what your base is going to be and what power it's going to be raised to. Okay. All right, these are all really good ones to look at. What other ones shall we take a look at? You guys feeling better about 6.6 now? You can do those.
No, I actually think I'm going to struggle with the last one, which I think is 6.8.
Yeah, and we're going to definitely go over 6.8. 6.8 is kind of crazy.
Yeah.
Yeah, what about 6? Oh, go ahead.
And then there was another one that I was having issues, and I think it was finding the percentage if you buy a car. And that's it.
Finding the percentage.
Yeah. The amount of the how much you will be spending in a vehicle. Yeah, I don't know how you call that.
Like in 6.2, where they talked about compound interest.
Yeah.
Yeah. So was it the depreciation one, or?
I think so.
Or was it the compound interest?
I need to step out real fast. My daughter needs me.
Okay, why don't you look and see what question that was too, and then get back on and tell me which question specifically, okay?
All right, thank you.
Yep. All right, so we'll go back to that. How about 6.7? How are you guys feeling about 6.7, solving logs? Maybe some of you haven't done it in class yet. There might be quite a few of you that haven't done 6.7 and 6.8 yet. Anybody? Those of you that have done it in class, how did you feel about 6.7? Yeah, Alex?
Can you hear me?
Yeah, I can now.
Okay. Yeah, I have a question on one of the practice examples for 6.7.
Okay.
You ready?
Yeah, what does it say?
All right. So it'll be log base 5.
Okay.
And then parentheses 1 over 625.
Okay, so it's a fraction. Sorry, so 1 over 625.
Yes. And parentheses equals m.
Just m? Just some variable?
Yeah, just m.
Okay. All right. So remember, when you're trying to solve these logs, right? So we're trying to solve for m. Try and figure out what m is. The easiest way to do that is to change this to exponential form first, right? So I'm just going to put down here to solve logs, right? Usually, easiest to change to exponential form. Okay, so I would always try and do that first. Try and change it to exponential form and see if that helps you. Okay, so we'll have 5 to the m power equals all the stuff inside the parentheses. All right, so let me rewrite that out here. So we've got 5 to the m power equals 1 over 625. Okay. Now, it does look kind of weird. Again, you know, we have a fraction over here. Okay, but kind of like I talked about up, you know, here on this last one, we were trying to get 8 and 16 to be the same base. Even though this is a fraction, we're still going to do the same thing. Okay, so 5 is already prime, and so it can't break down to anything more than 5. So we're thinking that 625 will probably be 5 to the something power. So let's break down 625, right? And so if we say like 625 divided by 5 is 125. And then 125 is 25 times 5. And then 25 breaks down to 5 times 5, right? So we can see, all right, so 625 is really 5 to the 4th power because it's 5 times 5 times 5 times 5, okay? And changing it to this form is going to make this a lot easier for us, okay? So let's do that on the next step. So I'll have 5 to the m power equals 1 over 5 to the 4th power. Okay? But now we don't want to have our 5 to the 4th power on the bottom, right? Because we have our 5 to the m power, right? It's, you know, if it was a fraction, it would be on the top part of the fraction. So we're trying, the next thing we want to do is flip this so it's now upstairs instead of being downstairs. And remember we said when we're flipping, you know, the numbers from top to bottom, that just changes your exponent from, you know, positive to negative or negative to positive, right? So flipping it up and down does that. So that means when I flip it upstairs, I'd have 5 to the m power equals 5 to the negative 4th power. Is everybody with me there? And then all I have to do at this point, right, is now my bases are the same, so I can set my exponents equal to each other. So that means m equals negative 4. And so that would be your answer. Mm-hmm. Does that help?
Yeah, that's perfect. Thank you. And then as you were going through, I started realizing that it was probably a negative number because of the fraction on the opposite side.
Exactly. So I'm glad you see that, right? So when you're taking the log of a fraction, your answer over here is going to be a negative number. right? It has to be because of, you know, what we know about exponents and stuff, right? And so like, yeah, let's go back up. I want to kind of explain. I feel like a lot of people just, they don't really get what's going on with logs. Like, you know, like, I don't know. And I don't know why it is. Sometimes I think it is maybe the way it's presented sometimes. And other times I think that it might be just, it just seems hard, right? And so people are like, oh, you know, I don't really, you know what to do here. And it just sounds so hard. So I don't want to, you know, try and do that. So I'll just pick a different one here. So I want to have you think about something here. If I asked you, let's see, I want to say this. Do something kind of like that. Just going to make one kind of like this, but a little bit easier. So let's say if we had, I'm trying to, hold on for just 1 second. Let's just look at something like this. What if I said, what is log base 2 of, let's say, 65? Okay. So remember, when I'm trying to find the log of, you know, when I'm, you know, doing this operation of log, what I'm trying to find here is the exponent, right? So this is the exponent that I'm trying to find. And remember, if I write it in exponential form, right, this really says 2 to the what power, right, gives me 65. Right? And so if you were to try and do this on your calculator, okay, so I want everybody to do this with me. Just humor me here. I think it will really help solidify what's going on. All right, so I want you to think about, well, what do we know about, actually, let's do 68. Sorry, hold on. All right, so let's do 68. So if we know, I want to think about, I'm going to write over here, all right, so I know that 2 to the 4th power is 16. I know that 2 to the 5th power is 32. 2 to the 6th power is 64. And 2 to the 7th power is 128. Right? And so this is when we have like, so whole number answers, right? So do you see that this 68 is not one of my numbers over here? And so that means that my answer is going to have to be somewhere in between there. So do you guys agree that 68 is somewhere between 64 and 128? Right? It's in between there. And so that means that my answer, my decimal, right, my exponent on here is going to be a decimal between 6 and 7. So I know it's going to be 2 to the 6 point, something, something, something power. And so that's what I'm trying to figure out. Okay, so on your calculators, I want you to try this, okay, because this is kind of helpful to see what's happening. So if you do, 2 to the 6.1 power, well, that's pretty close to 68, but we could get even closer than that, right? Because it says if you do 2 to the 6.1 power, it's 68.59, blah, 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 okay? So that's going to be, I guess, a little bit high, so we don't want that. Let me get rid of the 1 there, all right? That's a little bit too high. I'm going to try and write it over here a little bit. So 2 to the 6.1 power is about 68.59, blah, 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 blah. Okay? But we want we want it to be 68. So we're going to have to do, 6.0 something, right? And so maybe try and put in 2 to the 6.05 power. And let's see what that gives us. Oh, man. All right, and that gives me 66. All right, so now that's a little bit too low, right? So 2 to the 6.05 power is 66. So that means I need to make this 5 bigger, right? And so maybe I'll go up to 8 or 9 or something like that and see what I get there, right? So 2 to the 6.0, I'm going to try 09 power, right? And so that gives me 68.11. All right, so now that's over 68 again, right? So I've got to make it smaller. So maybe 2 to the 6.08 power, right? Do you guys see what I'm doing here? I'm like trying to figure this out by kind of just putting in some of these numbers. All right, and so that, if I do 2 to the 6.08 power, that's 67.6. So again, that's, lower. So, okay, so I know this is going to be an 8 there next. But now I need to try and get even closer, right? So I'm trying to get to 68. So now I'm going to do 2 to the 6.08 and then put another number there at the end, right? So maybe we'll try 5 or something like that. So try and figure out what's 2 to the 6.085 power. All right, and that's still not quite close enough, so I'm going to try again. Do 2 to the 6.08. Maybe I'll try 9, see what that gives me. And that's really close. So 2 to the 6.089 power, right, is 68.07. All right, so that gives me something pretty close. But it's still not all the way, right, to 68. So this thing that we're doing here, right, that we're trying to figure out what this exponent is, the logarithm is actually the shortcut way to do that, right? If you're taking the log, then you can figure that out. Now, most of your calculators don't do logs in different bases. They'll just do the log base 10, but some calculators would. But if you were able to put this into your calculator, log base 2 of 68, right, then you get an answer that would say, 6.089, blah, 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 blah.
Yeah.
All right? Are you with me there? Kind of seeing what we're doing? So, look at all of this that we have to do, right? This is a lot of work to try and figure out what that exponent is. So just being able to take the log of it, right, undoes it, and then we're able to figure out what that exponent is a lot easier. Okay? Does that help you understand what we're doing when we're trying to find logs? Maybe some of you already understood that, and I hope so. But if not, I hope that really helps understand what it is we're doing. Okay. All right, I was thinking about having you try and do just one other one here so you can kind of see. So let's have you just play around with one other one here, okay? So this time, right, if we're trying to figure out what the log of 2,500 is, right? And without using your calculator, okay, I want you to try and, well, you can use your calculator, but don't use your log button yet. But what I want you to see, right, when we're trying to figure out what this is, remember that if it doesn't show what your base is there, that your base is 10. So we're doing 10 to the what power equals 2,500, right? And then again, if we think about our powers of 10, right, we know like 10 to the third power is 1,000. 10 to the fourth power is 10,000. And so 2,500 is a number that's between 1,000 and 10,000. So again, I know my answer is going to be 10 to the 3 point something 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 power. All right? You guys with me there? Okay, so I want you to try with your calculator doing what we just did on that last part. And I want you to try and estimate that out. And I want you to go out to 3 decimal places because that's going to get it close to 2,500, okay, 2,500. So everybody, let me give you just a couple minutes. I want you to try and do that. And when you get a decimal, like out to 3 places, it gives you something close to 2,500. I want you to just raise your hand on the little box to show me that you are there. All right. Shayla, will you share with us what did you get out to 3 decimal places? You can write it in the chat box if you want. All right, yeah, so 3 to the 3.398, right, gives you something really, really close, right? That's, you know, just a little over 2,500. So that looks really good, right? And then, so now try on your calculator, right? So since our calculators, our logs are in base 10, if you just do what is the log of 2,500, right? So do that on your calculator. So log of 2,500 gives you, right, that 3.39794, right, blah, 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 right? So look at, we were pretty close there, right? Because that 9 here would round that up to be an 8. Right? So we just went out to 3 decimal places. But remember, these keep going on and on and on forever, right? Just the decimals are never ending, non-repeating, right? So, but this gives us kind of an idea of where it's at, right? And that's what we are finding when we are figuring out the log, right? What that exponent is on whatever base we're dealing with. Okay. All right. Well, hopefully that was a little bit helpful in understanding that more. All right, there was another question somebody wanted to look at, so let's look at this one now. So let's say we have log base 4 of 5x minus 1 equals log base 4 of 2x plus 1. Okay. And this is on 6.7 also. Okay. And so when you have a log on each side of the equation, it actually makes it a lot easier to solve it. And you have to have the same bases. So notice that this is log base 4 and this is log base 4. And if those are the same, right, remember how we said if our bases were the same when they're exponentials, we can set them equal to each other? Well, the same thing is true with logs. If our log bases are the same, then we can set, it's called the argument. I don't really like that. That's what they call it, but that's what this part of the log is called. You can set those parts equal to each other. So we have 5x minus 1 equals 2x plus 1. And then you're just solving it for x from there. And so as long as you remember that, you know, if the bases are the same, you can set those other parts equal to each other, then it is so much easier to solve, right? I'll add the 1 over, so 3x equals 2, and then I'll divide by 3. So x is 2/3. Be my answer there. Okay.
I have a question in one of the homework that's in the 6.7. Did you say log base of 6x equal 9? So I don't know what to do in that one.
Okay, say that one more time. It says log
base 6 x,
just x?
yes, equal 9.
Okay. So remember that you're going to always, whenever you're solving logs, right, you want to change it to exponential form first. Okay, so how do I change this to exponential form? Remember? So I start with the base on my log, and I raise it to this power, and it is equal to this, right? So it's saying, so when I change that, I'm saying 6 to the 9th power equals x. And then all you have to do is just put in your calculator what is 6 to the 9th power. And it gives you a big long number, but that's what your answer is. So it's like 1,0077696. Right? So it's like 10 million. Right? But yeah, so I say make sure you remember that whenever you're asked to solve logs, right, you want to always change them to exponential form. So if you get stuck, right, on, you know, the the quiz at the end of Module 6 or on the final exam, right, on how to change these to exponential, or how to solve these logs. I want you to always think in your mind, okay, let me try and change it to exponential form and see if that will help me. And I would say, 95% of the time, it is going to help you, right, to change it to that exponential form. So I would always start there first. Okay. All right, let's see. Anything else up to 6.8? Because I was going to do 6.8 next, unless there was other things that you wanted to talk about there on anything up to that point. Okay, let's take a look at some of these together. I think number 2 would be a good one to look at. If there's some that, that you want to ask about, you can. I was thinking about doing number 2, 6, and 7, but how does that sound to everybody? Those of you that have tried them, maybe you kind of know which ones that, you're kind of like, oh, what am I doing here? But I think if we go through those 3, I think you'll be able to get the rest of them done and stuff. So, all right. So let's look at this one first, right? So it says, the 1906 San Francisco earthquake had a magnitude of 8.3 on the Richter scale. At the same time, in South America, there was an earthquake with a magnitude of 5.4 that caused only minor damage. How many times more intense was the San Francisco earthquake than the South American one? Right? And then it wants us to round our answers to the nearest hundredth. Right? And it's kind of, interesting. I mean, maybe, if you're in Salt Lake and you felt kind of the earthquakes that have happened over the last month, it's kind of interesting to, think about this and stuff. What was the largest earthquake that we had in the last little bit? Does anybody remember? I think it was in the 5s. 5.7. Okay, so a little bit more, right, than the one there that was in South America that they're talking about, the 5.4. And really, we didn't have a lot of damage, right, from the 5.7 earthquake. But if things get, like if you have above a 6, right, that's usually where you see more damage happening. And, 7s are really bad. And then 8s, oftentimes will, just a lot of rubble everywhere, right? A lot of things fall down. And so, has anybody been in a larger earthquake? Just curious. Because I haven't, but some people, like I have some friends and family that are from California, and they're like, 5.7, that's nothing, we feel those every day. I'm like, okay, well, it's something to us. So, but, all right, so let's look at this. So it doesn't tell you, on here, the formula that you're using, but you should have, if you watch the video there with it, it will kind of help you, it'll tell you what the one is that you're going to use. But in those videos, they are kind of using some different formulas and stuff like that. I mean, a little bit, and so that can throw some students off, but it's just because there's more than one way that you could get to the answers on some of these questions on the 6.8 homework. Okay. Okay, but so we want to use the formula. So let's see, I'm just going to say this is 6.8 homework number 2. So the first one we're going to do here. Right, and so we're going to use that formula. So the magnitude, right, of the earthquake equals the log of x over 0.001. Right? And then maybe just kind of understanding, you know, what each of these things mean is, you know, something that you might want to look at and stuff. With the Richter scale, right, the X on there is a seismograph reading, right? So a seismograph is what they use to be able to detect earthquakes, and so it's like how large the how long in millimeters, right, there is on that seismograph reading, right? So it kind of like goes up and down, you know, like, and when there's like kind of a spike in it, you know, then you can kind of see that there was an earthquake at that point. So that X is just kind of meaning, you know, the millimeters on there. And then that 0.001 on the bottom, right, is basically kind of like, if we're dividing by that, because under that amount, you're really not feeling any of the earth movement and stuff like that. So it's kind of helping account for some of that. Okay, but just kind of understanding what this means. And then this M of X, that is the actual like Richter scale reading. That is the magnitude. Okay, so on this one, we're basically going to be looking at two different problems simultaneously, right? So we have to do one for the 8.3 earthquake, and we need to do one for the 5.4 to be able to determine how many more times intense the one was from the other. Okay, so let's do the one in San Francisco first. All right, so let me write here. So for the San Francisco one, okay, we've got 8.3 equals log of x over 0.001. All right, so I just put the magnitude in there. That's all I did so far. And now I'm trying to solve this. And remember, when we're solving logs, right, just like I just got done saying before we left for break, the best thing to do when you're trying to solve logs is to change it to exponential form. So that's what I'm going to do. So since it doesn't show what my base is, that means it's a common log, which is a base of 10. So I have 10 to the 8.3 power equals all of this stuff inside the parentheses. Right? So let's rewrite that down that way. So I've got 10 to the 8.3 power equals x over 0.001. Right. Is everybody with me there? Or do you have questions about how I set that up or what I was doing? Okay, then I'm trying to solve for x. And so right now, right, x is connected to this by division. So I want to multiply both sides. I'm going to multiply this side by 0.001 because then it will divide out there, right? And I'll just be left with x on this side. But if I multiply that side by 0.001, I've got to multiply my other side by that as well. Okay. So then, in your calculator, just go ahead, I mean, maybe I'll write this down a little differently. So x equals 10 to the 8.3 power times 0.001. So figure out what your 10 to the 8.3 power is, and then times it by 0.001. And what do you come up with there? You can go ahead and write it in your chat box if you want to. And So you're doing 10 to the 8.3 power. Some of your calculators will have to press equal after that, and then times that number by 0.001. Okay. All right, so awesome. So David said he got this number. Alex got the same thing. Okay, so that looks good. All right, so now, right, we're going to kind of stop there for a second because now we need to do the same thing for the South America earthquake, which had the 5.9%, or, no, 5.4 earthquake. All right, so I'm going to put here, so this is going to be our South America one. All right, and so we're going to have 5.4 equals log, you can go ahead and put your base 10 in there if you want right now, of x over 0.001. Okay, so I want you to solve this one the same way we did on the other side. So let me give you just a minute and try and come up with that. Okay, so when you get that number, all right, let's put it into the chat box too. See what you guys are coming up with. All right, and I'm just going to go out to 4 places there. That should be enough for this one. Okay, so we have one more thing that we need to do on this, but what questions do you have up to this point? Like, make sure you're speaking up. Does everybody understand how we came up with both of our answers here? Okay, then I want you to look over here in the question again, because this is going to be kind of telling us the way we need to do our next step. So notice it says, how many more times intense was the San Francisco earthquake than the South American one? So notice the order that they're writing it in, right? San Francisco one was more intense. And so your next step is you've got to divide, right, the San Francisco one, right, by the South America one. Right, so you're going to take that and do the San Francisco one. So you're going to put that number on the top. And then you're going to divide that by the South America one, right? We came up for X there.
The dog.
Okay. And then what do you guys come up with there for your answer? And it says to round to the nearest hundredth, right? So we just need to go to 2 place values. So let's round it there. Okay, so when we divide that, we get 794.33, right? And this is how many times, right, more intense the San Fran earthquake was. Oops. Wow. Okay, so that's what we're doing there. So you got to find both of them. So it's kind of like 2 different problems, and then you got to divide them in the end. Okay. Questions on that? To do there? All right, let's go to, so it seems like usually number 6 and number 7 tend to be other ones that students really struggle with on this assignment. So let's look at those too. And it's talking about half-life, right? And so each element, right, is going to decay at a certain amount. And so they talk about this half-life, and that just means like that half of the element has decayed in that amount of time, right? And so we're talking about this radium 226, right? And so when we're looking at this, let's see, let me put up here. So this is question number 6. Right? And like I said, you might have some different numbers than the ones I have, but that's okay. It's still going to be kind of the same idea here. Okay, so the half-life of radium 226 is 1,590 years. If a sample contains 400 milligrams, how many milligrams will remain after 2,000 years? Right? All right, so first of all, we've got to know what this half-life equation is. All right, so let's look at that first. And so the equation that is usually given for this is 1/2 A equals A times e to the RT power, right? Where E, remember, is just that constant that we've talked about, that's like that 2.72, right? So this E is not a variable, right? It's a letter, right? But it has a specific meaning to it. So it can't just be any number, right? It's going to be that 2.72, right? R is going to be our rate of decay, and T is the time in years, okay? And this A on these kind of gets a little bit tricky because A is talking about the percent, right, of decay, right? That is like the percent in which it's decaying there. And so that's kind of one of the things that we have to look at here, and that's what we're trying to find out. So again, this problem, we're trying to figure out how many milligrams will remain after 2,000 years, is kind of going to take 2 different parts to figure this out. All right, so the first thing that we want to do is we're going to just, so 100% just is 1. And so what I'm going to do in this is I'm just going to replace the A's with 1. And so really on this, it's going to be 1/2 equals E, and then I'm going to replace that, you know, so I'm trying to figure out what my R is on this. I want to know what my rate of decay is, so I'm going to try and figure out what my R is, but I know the time that it gives me is that 1,590 years, okay? That's the half-life of it, so that's what I'm going to put in here in place of my T. So that's going to be that 1590, right? That goes there. All right, so now I need to solve this for r, right? And remember, talking about some of the things we just did in 6.7 and 6.8, or sorry, 6.6, 6.7, right? We talked about in order to solve, right, something that is e to the something power, right? We're trying to solve for this exponent. The way I am going to do that is by taking the natural log of both sides, right? So I'm going to take the natural log of this side and the natural log of this side. And remember, I'm doing that, I've got to take the log so that now whatever is my exponent can come out in front of this natural log of e and be multiplied by it. Okay, so let's see, this looks a little bit, let me try and rewrite this a little bit, move my equal sign over here a little bit more so you can see that it's still going to stay on the right side of the equal sign, right? But it's just going to come in front of this natural log of e. All right, so I rewrite this out, and I've got the natural log of 1/2 equals r. Actually, let me write this as 1590 times r. It's easier for my brain if I have that number first. So 1590 r times the natural log of e. Now, what did we say before? I said natural log of e is something I want you to memorize. What is the natural log of e? Anybody remember? It's 1. Okay, so that makes this a lot easier to solve for. So it's kind of like that's just gone now, because if we multiply by 1, right, that's not changing anything here. So then to solve for r, I just need to divide both sides by the 1590. Okay, and so then in your calculator, you need to figure out what's the natural log of 1/2, and you could put it in as natural log of 0.5 if that's easier for you than, writing the fraction. It doesn't matter. All right, so the natural log of 0.5 divided by 1590. Right, and the 1590s on this side cancel out because we're trying to get r by itself. Okay, and we can't say exactly what it is, so I'm going to put this little approximate symbol, right? So it's about, let's see if you guys came up with the same thing I did, negative, let's see, 0.000436. All right, I'm just going to take it to there. Is that what you guys got? If not, please speak up. Okay, if you have a question on this, somebody else has the same question, so please, please, please speak up. I can't see you guys. I can't tell what you're thinking. If you're with me, if you're not. Okay, so that's the rate, right, in which, and the negative is on this because it's decaying, right? So that makes sense to me that we came up with a negative number because we're talking about the decay rate, right, of this element. And so now the next part of it, we're going to use what we found for our r here, right, and put it back into our formula here that we have. Okay, so let's go back up here, and now, let's see, it's kind of a different, all right, so we're trying to figure out now just what, how much is going to remain. And that's going to be what we have here on the front, what that is, how much is remaining. So when we put this in, right, so we're going to kind of go back to this equation here. But the amount, right, that we're dealing with, so it says that we have 400 milligrams, right? And so we're going to have that as kind of the start amount. And so that's what's going to be taking place of our A here. So just going to kind of write it down this way. So I'm going to have 400, right, times e to the r times t power. All right, well, r we just found to be this number down here. So that's going to be that negative 0.000436. And then our years, as we're talking about in 2,000 years, how many is going to remain after 2,000 years? So our 2,000 goes in there. And then what we're, figuring out is, how much is going to remain, right? That's what we're kind of, our end amount is here. I'm going to put it as a capital A. That's usually how we see it. Okay. And so let's figure out what this equals. All right, so you've got to do, and on this, it's a little bit tricky to figure out how to put in your calculator if your calculator won't accept all of these things. So you might have to do, figure out what the power is first, and then if you know how to store that into your calculator, all right, sometimes there's an STO button, all right, so there's kind of a little button that looks like, it says like STO, and sometimes it has a little arrow after it or something too. All right, so it either is that or it kind of has like a little arrow. All right, and that's usually like the store button, or in some calculators, it's you have to do like your memory, your memory save. I'm trying to remember what that looks like on the calculators. So sometimes it's just like an M plus, right? It's kind of where it's saying like your memory to save. And then to recall it, you have to hit your MR button. So understanding some of these buttons, right, on your calculator can really be helpful on this, just because there's so much that you have to do here. Okay, but if you multiply these together, raise it to the power of e, and then times it by the 400. But some of your calculators, you can put that all in just how it's written there. Okay. Let's see what I come up with when I do this. Okay, so I ended up with, it says, is there a way to round our answer to the nearest hundredth? So I came up with 167.25. All right, and this is how many milligrams remain, right, after 2,000 years. Okay, were you guys able to come up with that? You guys are being so quiet now, and sometimes that worries me. So I'm like, are they getting it? Are they not? Will somebody speak up and let me know where you have questions on that? Or if you don't have questions, tell me that too. Or if you're so lost, you're like, Becky, I don't understand, but I don't know where to ask a question because I feel so lost. I know that happens too sometimes. Nobody's saying anything.
I got a different decimal, but I think it was because I stored the original long decimal.
Okay, but it's pretty close to that, isn't it?
Yeah.
And it will, like I said, on your homework, it's actually, they have built into it kind of a little rounding error. So as long as you're not off by too much, it'll actually still mark it right for you. Okay, so if you came up with something, you know, pretty close to that, but yeah, I didn't save my whole number here. This is what you were saying. You saved your R. Yeah, as the whole long thing. Yeah, so that's going to change it a little bit there, but really in the end it should still be the same. And your answer is more correct than mine by not rounding it. But so yeah, I would just go with what you have there. But yeah, some people.
No, I know on the final you said we're allowed to use notes, but are these formulas going to be given to us?
They're not going to be given on the test. So, so what I was going to do next time, so if we're going to meet next Friday, right? Remember, it's not required for our class. Today is the very last day of our class that I'll be taking attendance for, but I'm still going to hold class, and I'll send an announcement to you guys to remind you. I'll still be holding class, and we'll just review for the final on that day. But like I said, it's optional, but I think it will be really beneficial to you, because what I'm going to have you do is we're going to kind of go through and figure out, like, let's make up a sheet of paper like that has all of the formulas on it that we might need, you know, and stuff like that. Because since it is still timed, right, you have a 2-hour time limit to get this done, you want to make sure that you're really organized, right? So a lot of times students take the approach of, oh, well, it's open notes, so I don't really need to do anything. I can just, you know, look at what I have. But I would caution you that you might run out of time if you take that approach. And so we're going to get together, you know, the next time and talk about, okay, what things should we put on our notes? Because remember, you have to have your own notes written up to be able to use on this. Okay, and these are definitely going to be some of the ones you'd want on there. However, I will say this, and I haven't seen the final exam for this class yet, but I'll just say I've never seen any questions off of 6.8 be put on the final exam. So it's not that they couldn't be, but I've just never seen them do it, right? So for some people are like, oh, good, because that is stressing me out like crazy, right? And so, so just know that you know, these might not show up on there. However, they will for sure show up on the quiz for Module 6, right? You will see them there, okay? Okay, thanks, Alex. So he said they haven't talked about this one in class, but he feels like he's following it pretty well. Okay, good. Yeah, and it is, like I said, these are kind of crazy story problems, and you're going to be talking about logs more in 1010 and 1050, so that's kind of why I think they haven't ever put them on the final exam, because they know that you're going to be dealing with these again over the next 2 classes, and this is really more of the scope of 1010 and 1050 stuff with logs than it is for 980, so I think that's why I've never seen it there. Okay. All right, well, we didn't realize that the time was almost up there, but let me we won't go through question 7. I'll let you guys do this, but I want you to think about, I mean, there's just kind of the same thing, remember, that we did on, you know, this one where we had to compare San Francisco, we had to compare South America, and then we divided them in the end. That's the same thing that you're going to do on number 7, but now you're comparing these 2 different things, right? So you're comparing the noise of this hot water pump to the noise at a rock concert. And then it says, and you've got to make sure you read this last line well, so the rock concert noise is how many times more intense? So remember over here how we had to put the one that was more intense on the top and the one less intense on the bottom. So you've got to make sure you're doing that division right. So you use this formula, right, to do that. And, you know, and we can look at this next time too, if you are still not quite sure, you know, how to do it. But you're going to use this formula and know that you're not going to put anything in for that P of 0. That, I think, throws a lot of people off, and they're like, wait a minute, you know, what am I doing with that P of 0? At some point, the P of 0s are going to cancel out, And so it's not going to be something that you're going to have to deal with. So, so anyway, so just kind of know that that's kind of what's happening there with those. So that P of 0 is not really something you need to worry about. But okay, try and watch the video for it and see what, how you can do that before you try it. And then reach out to me if you still have some questions about it. But like I said, it's kind of similar to number 2, where you have to do 2 different parts of the problem, and then you're going to divide the answer in the end. Okay? And I think if you know that, a lot of times it will really help you get there. Okay? All right, guys, can you believe the semester is, you have 1 more week of classes left, right? 1 more week. And then it's finals after that. So make sure you bring, those of you that are going to be coming to the review session next week, please bring any questions that you have. Oh, also our review session, and I'll put this in in an announcement that I send to you. I'm not going to do it in our regular WebEx classroom. I'm going to put it in my virtual office, so that students from my other 980 classes can also come to this review session. All right. So just know, and I will record it also, just like I usually do, and then I'll get those put up, in our class on that front page and stuff. Okay. But I'll send you a message just to remind you about that. Okay. Any other questions? Hey, I hope today was helpful for you. You guys are so close. Keep up the good work, and you're almost there. So hang on and reach out to me when you have questions, okay?